purpose of today's lesson is to graph and evaluate exponential functions. So let's take a look at the do now. There are two options that your soccer team has. They're going to practice 5 minutes today and then add a minute each day. Or they're going to practice a minute today and then twice as much each day as the previous day. So what's going to look like after 5 days? Well, let's divide this into two. Here's option 1. Here's option 2. And we're going to let today be day 0. So here's our day, and here's the time, minutes. Okay? 1, 2, 0, 1, 2, 3, and 4. So today, we're going to practice 5 minutes, and we're going to add a minute each day. All right? And then here, we're going to practice 1 minute. The next day is 2 minutes. The next day is 4. The next day is 8. And the last day is 16. Now, how would we write an equation for each of these? Well, the one on the left is pretty straightforward. What would we write? Y equals x plus 5. If we let the day be x and the minutes are y, you can see that you add 5 to each day. Now, what does this one look like? Well, here, hopefully you can see that it's y equals 2 to the x power. And why is it 2? Because we were doubling the amount of time spent practicing each day. Now let's take a look at the table of values here. In the first table, you should be able to see that I have a constant rate of change of plus 2. Constant rate of change is associated with a linear function. While in this one, hopefully you'll see that I have a rate of change of times 3. Well, for the first one, you should be able to write this equation, y equals 2x minus 3. And then hopefully you see in the second one that this would be the equation y equals 3 to the x power. Right. What we've just seen here is what is called an exponential function. And an exponential function is defined as a function in the form y equals a times b to some power, where a doesn't equal 0, otherwise we don't have anything. B is greater than 0. B doesn't equal 1, otherwise there's no impact to it. And x is a real number. Okay. So let's go through a couple of examples. I want to write the exponential function rule represented by the table below. So the first thing is, how do we know it's exponential? Well, hopefully you can see it's times 3. Now, the first plan of attack would be to say, well, it's y equals something with a base of 3 raised to a power, because it's times 3. Well, if we take each of these x values and raise them to the third power, or use them as my exponent, I would get 1 here, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, and 3 to the fourth is 81. And that doesn't give me the number here. So something else is happening. What else is happening? Well, I'm multiplying each of these results by 2. So that's how you get the equation. What is the graph of an exponential function? It's a continuous curved figure. Okay? Now, the domain and range are the same concepts as we've talked about. Now, just give me a second, because what I want to do is call up, and hopefully it'll work, our graphing calculator, because we're going to use that in a second to do our graphing here. Okay. Now, the domain, as you remember, is the set of x values, and the range are the set of y values. Okay. So in concept, they are the same thing that we have previously dealt with, but we want to make sure you understand. Okay, let me just enlarge this and then get this out of the way for a moment so I can put in our definition. In our particular case with an exponential function, unless given a specific domain, it is the set of all real numbers. Okay? So unless I tell you use these x values, every x value is up for grabs and can be used. The range is a little bit trickier. It is based upon the y value that the curve will never obtain, depending upon the curve. It will be a value greater than or less than such y value. Now, if right now you're saying to yourself, I have no idea what he's talking about, it should hopefully be a lot clearer once we go through some examples. Now, the way to do graphing of a exponential function is set up a table of values that you're going to use based upon what you're going to put into the calculator. Okay? Now, you want to use the calculator as much as possible to help you here. And you've got to be careful with what values you're going to use, because since it's exponential, these numbers can get very large and very small quite quickly. So we're going to go to our y equals, and we want the exponential function y equals 2 to the x power. So put in 2 caret x. And now we're going to just call up our table of values. Now, one thing is you'll see that the calculator puts the values in decimal form. So if you put them in decimal form on your graph, that's fine. But here's the main point. If you take a look at the curve here, what you're hopefully noticing is that the curve will bottom out very close to the x-axis, but it will never hit the x-axis. Now, why will it never hit the x-axis? Well, for it to hit the x-axis, that means y would have to be 0. And it's impossible for 2 to some power to equal 0. It never will. What will happen if you were to scroll up on your calculator, you'll see that my values are getting infinitely smaller as the exponents get smaller, but they will never, ever reach 0. It's an impossibility. And that's what we were talking about when I was telling you about the range. So here are the values that I'm going to put in. There's no magic to how many. It's just enough to get a good idea of my curve. You want to use numbers that are not infinitely small or large. So I'm going to plot these 5 points, -2, 1/4. Now, is it going to be exact? No, but it's reasonably close. And what's key is when you draw your curve, again, put your arrows, you're making sure that you don't have it running towards the x-axis. So my domain, x is all real numbers. And why is that? Because these curves will go out forever. And if you notice, my curve is bending to the right because this will slowly keep creeping out. All right? My range for y is greater than 0. Not equal to, greater than 0. Because my y value will never hit that x-axis. Okay? So let's do a couple of other examples. Now, I'm putting two of them on one graph here so we can contrast the two. All right? So let me just divide this up in here. All right. So for the first one, y equals 3 times 2 to the x power. Now, again, it's the same values here, or similar values, to what we used before, and that is just merely a function of what the calculator tells us and what I can get onto the graph. So negative 2, 0.75, negative 1, 1.5, 0, 3, 1, 6. So it's going to look, again, something like this. The domain, x, is all real numbers. And my range is, again, y is greater than 0. Okay? Now, we take a look at the next one where it's y equals negative 3. Please be careful when you put that negative 3 in. The negative sign is the negative sign below the 3 on the calculator. And what you're hopefully noticing is that all that's happened is my signs have changed for my y values. And my graph is going to look something like this. And it's the same, and I'm not, my orientation's a little off, so it's not really hitting the x-axis. So it's the same graph, except it's upside down. Now let's make sure we understand our domain is still all real, but my range is a little bit different because it's y is less than 0. It's every y value below 0, okay? All right, let's take a look at the next example. I'm telling you to use these specific x values, okay? Here's my curve, okay? Now, if I tell you to use those specific values, then your domain are those specific x values. Your range are those specific y values. Okay? So that's the only difference that we have between them. All right? Next two examples. Now we're going to be adding or subtracting a value because I want you to see how that looks different. Okay? So again, I'm going to do these two here. You would be getting all of these values off of the calculator. Okay? So negative 1, 1.5, 0, 2, 1, 3, 2, 5, 3, 9. So it's going to look something like that. Your domain, x is all real. Now, What about your range? Well, since I'm adding 1, what it did was shift or translate my curve up 1. So now my range is y is greater than 1. Because by adding 1 on, I shifted it up 1. So now it bottoms out there. Okay? It'll never hit there. Now let's do it with subtracting 1 with the same. Okay? So now I have -1, I'm at -0.5, 0, 0, 1, 1, 2, 3, 3, 7, and you'll see it's going to run right next to it. It's the same curve, but now it's been shifted down. My domain, x is all real, and then hopefully you'll see that your range is y is greater than -1, because it'll bottom out down here. So by adding or subtracting, what I've merely done is translated my graph up or down. Okay? Then lastly, I have y equals 1/2 times 2 to the x power. Again, you're plugging this into your calculator. You're not doing this by hand to get these values. Okay? You're going to plot the points. Okay? And d, x is all real, which again will always be the case unless I give you the domain. And a range y, it bottoms out at 0. Okay? So what we covered today was the graph and exponential functions.